Number 68 says, consider the following three spheres which represent atoms in the same period of the periodic table. Which atom has the highest atomic number? Which atom has the largest ionization energy? And which atom gives up an electron most easily? So here, these atoms, you can see the one on the right is the biggest one. The one on the left is the smallest one. Now they're in the same period. And atoms in the same period, you might think that they get bigger as you go to the right across the periodic table. Let's just look at the periodic table for a moment. So if you got atoms in the same period, like maybe carbon, nitrogen, oxygen, you might think that as you go to the right, they would get bigger, but that's not the case. When you go to the right across a period, the atoms actually get smaller, okay? Kind of counterintuitive because oxygen is a heavier atom than carbon. And the reason it gets smaller is because the oxygen has more protons in the nucleus, and the more protons are able to pull in those second shell electrons tighter. So as you go across the second period, the second shell electrons get pulled in tighter and tighter and tighter. But then, going down to the third period, those atoms are larger. But then as you go across it, they get smaller and smaller and smaller. And then the fourth period, on average, the atoms are larger. But as you go across, they get smaller and smaller. If you want to look at a nice representation of the size of the atoms in the periodic table, here they are. So this is a three-dimensional representation of the periodic table. You can kind of see these boxes are, the height of the box tells you the atomic radius. And so really the smallest atoms are up here on the top right-hand corner, and the largest atoms are over there. So as you go across a period, they get smaller and smaller and smaller. Now the atomic number increases, but the atomic radius decreases. So let's look at these three atoms again. Let's put that there, and let's look at these three atoms over here. So it looks like this one, if they're in the same period, this one would be on the left. Okay, so this one, let me just, we'll just draw that, and you got the big green one. Okay, let's just put them in the proper order. And then you have the medium-sized blue one. And then you got the other white one. I'll just draw that like that. So I don't know where these atoms are. Maybe they could be carbon, nitrogen, and oxygen, but maybe they could be this one, that one, and that one. They would be in the same period. Okay. Now that we have them in the correct order, okay, we know that this one has the largest atomic number, because as you go to the right, the atoms may get smaller, but the atomic number increases. So I'll just say the largest atomic number. Okay, and then the smallest atomic number over there. Now the next question, which atom has the largest ionization energy? So what is ionization energy? Here, I think we know what atomic radius is. Atomic radius is the distance from the center of the atom to the outermost electrons. Okay? Now, here's the connection between atomic radius and ionization energy. The ionization energy is the energy required to remove an electron from an atom. So if you have an atom and an electron is going to be removed, it's going to be the outermost electron, the one that's way out here. Now the larger an atom is, and the farther those electrons are from the nucleus, the easier it is to remove the electron, and the smaller the ionization energy. So looking at these three atoms, this atom is fairly large, and its outer electron is way out here. It's going to be pretty easy to remove it. It's not going to cost very much energy. The ionization energy is going to be low. Okay, but the smaller one, the outer electrons are closer to the nucleus, and it's going to be hard because, you know, the positive nucleus is pulling on it. It's going to be hard, and the ionization energy is going to be high. So I'll say over here, lowest ionization energy, lowest IE, and then, or smallest IE, and then highest IE. Now, the lower the ionization energy, the easier it is to remove the electron. Okay, it's easiest to remove this guy's electron, but over there it's hardest to remove it when the ionization energy is high and the electron, the atom is small. So hardest to remove. Sorry, it's kind of sloppy. Hope you understood that.